On one planet in our solar system, the sun rises in the west and sets in the east. Not because the sun is moving differently, but because the planet itself is. This is Venus, a world that seems to break the rules of space. But here's the real question. Did Venus actually break the rules, or did we misunderstand them? When you look at the solar system, it feels organized, almost predictable. Planets orbit the sun in the same direction. Most of them spin the same way too. Even Earth follows this pattern. This shared motion isn't random. It comes from how everything formed, from a spinning cloud of gas and dust billions of years ago. So naturally, we expect consistency. But Venus doesn't cooperate. Earth's twin, or its opposite. At first glance, Venus looks familiar. It's almost the same size as Earth. It has a rocky surface. It formed in the same region of space. That's why it's often called Earth's twin. But that similarity is only skin deep, because Venus is one of the most extreme places in the entire solar system. Its surface temperature reaches over 460 cm, hot enough to melt lead. Its atmosphere is incredibly dense, about 90 times the pressure of Earth, and instead of water clouds, its sky is filled with thick layers of sulfuric acid. Landing there wouldn't just be dangerous. The backward spin. But Venus's environment isn't the only thing that's unusual. Its rotation is even stranger. Most planets spin counterclockwise when viewed from above the solar system. Venus spins in the opposite direction. This is called retrograde rotation. Because of this, the sun appears to move backward in the sky. On Venus, sunrise happens in the west and sunset in the east. It's a simple observation, but it completely flips our expectation. And then there's time. On Earth, a day is shorter than a year. That's what we're used to. But on Venus, time behaves differently. It takes about 243 Earth days for Venus to complete one full rotation, but only 225 Earth days to orbit the sun. That means a single day on Venus is longer than its entire year. If you were standing there, you would complete a full orbit around the sun before experiencing a single sunrise and sunset cycle. So what could cause a planet to behave like this? Scientists have proposed several ideas. The most widely accepted theory involves a massive collision. Early in the solar system's history, planets were still forming. Objects were constantly colliding, sometimes gently, sometimes violently. One of those impacts may have struck Venus with enough force to reverse its spin. Imagine a spinning ball being hit hard enough to send it rotating the other way. But there's another possibility. Some scientists think Venus didn't flip suddenly, but slowed down over time. Its thick atmosphere may have created drag, gradually altering its rotation until it reversed direction. Right now, we don't know for certain which explanation is correct, and that uncertainty is part of the mystery. There is no wrong direction. It's tempting to say that Venus spins the wrong way, but in reality, there is no wrong way. Direction in space is relative. Clockwise, counterclockwise, forward, backward. These are human labels. The universe doesn't prefer one over the other. Venus isn't broken. It's simply different. And that difference forces us to rethink what we consider normal. Take Uranus, for example. Instead of spinning upright, it's tilted almost completely on its side. It's as if the planet has been knocked over. As it orbits the sun, one pole faces sunlight for years, while the other remains in darkness. Just like Venus, this extreme tilt may have been caused by a massive collision. These examples remind us that the solar system is not perfectly orderly. It's shaped by chaos, impacts, and unpredictable events. Even the sun is different. Even the sun, the center of our system, doesn't behave uniformly. It rotates too, but not like a solid object. Its equator spins faster than its poles. This uneven motion twists its magnetic field and leads to powerful solar activity, like flares and sunspots. So even the most dominant object in our system isn't perfectly consistent. So why do planets spin in the first place? The answer lies in the very beginning. About 4.5 billion years ago, our solar system formed from a massive cloud of gas and dust. As gravity pulled this cloud inward, it began to spin, faster and faster. Eventually, it flattened into a disk. At the center, the sun formed, and from the rotating material around it, the planets were born. They inherited that motion, that spin. This is known as conservation of angular momentum. Once something starts rotating, it tends to keep rotating unless something interferes. And in the case of Venus, something clearly did. Every spinning world we see today is carrying a memory of its origin, a trace of that ancient motion from billions of years ago. Some stayed stable, some were changed by collisions, some evolved in unexpected ways. Venus is one of those worlds. It doesn't follow the pattern. It doesn't match our expectations. And maybe that's the point, because the universe doesn't follow rules, it writes them.